We're going to solve number 44 using a couple of different methods here to find the real and complex solutions of this polynomial equation. The real solution is going to come from solving this the old-fashioned way. Add 27 to both sides, and then you take the cube root of both sides, and the cube root of 27 is 3. So the real solution to this problem is x equals 3. The other two solutions are likely going to be complex. So what I'm going to do is I'm going to run some synthetic division using one solution being 3, and then the numbers 1, 0, 0, and negative 27. Remember, those numbers come from the coefficients with x cubed, x squared, x, and the constant negative 27. So here we go. We're going to bring the 1 down and multiply by 3, add, multiply, add, multiply. Remainder, 0. That means that this problem does factor nicely, and x minus 3 would be one of the factors, and then x squared plus 3x plus 9 would be the other factor. And again, those coefficients and this constant come from the results of our synthetic division. So this original polynomial, x cubed minus 27, factors to this. And if you notice, it's actually the difference of cubes, which comes from your formula sheet. We have x minus 3. Oh, this was also called the SOAP formula. The same sign, negative, the opposite sign, positive, and then always positive for the plus 9. So yeah, that is the difference of cubes formula. And now we're going to find the other two solutions using the quadratic formula on the x squared part. So we're going to do the opposite of our b, plus minus the square root of b squared minus 4ac, all over 2 times a, which is 1. So we have x equaling negative 3 plus minus the square root of 9 minus 36 over 2. So we're going to have negative 3 over 2 plus minus the square root of negative 27 over 2. This will simplify to negative 3 halves plus minus 27 negative. We can break up into negative 9 times 3. The square root of negative 9 times 3, well, if we take the square root of the negative 9 part, we're going to get a 3i. And then the 3 is going to get stuck over 2. These are the other two solutions to the original problem. So we have our 3 solutions. The real solution, x equals 3, and the 2 complex solutions listed right here.